Hi everybody, this is Tor Storley, and I am back with another video. In this video, we're going to take a look at how you can create pro forma or vertical and horizontal financial statements, getting the data from the SEC Edgar system. And then what we'll do is we'll put them into a database. And then we want to create some files out of it, like a CSV file and Parquet files. And then finally, we want to take the data from the database and we want to create these statements and combine them and put them out on an HTML pages using Quarto documents. So I created this folder in VS Code. It's called Pro Forma, and there's 3 files in it. One is to get the data from Edgar, which is a Python notebook. The second one is to run some Python code that will actually generate files, etc. And thirdly, I have a Quarto document that's going to output it for these statements in one document. So, by the way, you might have seen this before if you watched my EdgarTools video in the past. I did use some of this code before to get the data from Edgar. So let me minimize this so we have more room. First thing we want to do is just import a bunch of libraries, pandas, NumPy, DuckDB. By the way, all of this is in my Python virtual environment. You can see on the top right corner here. Now, in order to get data from Edgar, you need to provide an identity. So I'm creating a fake email here just so I can get the ball rolling. And from Edgar, we're going to import company, set identity, and multi-financial. The reason we're using that one is because we want to create the balance sheet, income statement, and cash flow statements over multiple years. So by using this multi-financial, we can actually create a column for each year. So we can combine it. All right, so the first thing we're going to do then is run this. And this might take a few seconds to run, okay? And then we want to get the data from Edgar using the EdgarTools package. And I discussed this in the past. I'm not going to go through. If you need to look it up, just go and do a Google search for EdgarTools, okay, for Python. So we can use the company here and pass in. I'm just going to use NVIDIA for illustration purposes. So let's go and run that. And you're also going to see after it retrieves the data, it gives you just a splash screen about the NVIDIA company here, the corporation. Gives you some addresses, some people that are involved. Okay, so that's that one. Now what I want to do is I want to use the object we just created and get filings 10K, which is annual reports. And I'm saying latest. So what that will do is it will get the latest filing. So I'm not going to run this one because this is only going to get the last year, okay? But you can do that this way. And then what I want to do, I want to use this command because I want to get all the years. So in other words, this gets the latest. And here I want to get the last 6 years, okay? And I'm going to store into this variable. So okay, let's run that. Then you use this multi-financial from the EdgarTools package, and you're extracting the filings, which are these, and that will parse it out nicely. And then from there, I'm going to get the balance sheet, the income statement, and the cash flow statement. And then we're going to load them into these variables. Okay, so let's run that. I'm going to print the multi-financial, what type it is, and for income statement. So you can see, okay, this first one is a multi-financials object. And this one, as you can see, is a statement object like this. And it's stitched, as you can see, because there's more than 1 year in here. So now what we can do is we can take a look at it. So let's print that income statement out. And here you can see this is in its raw form. This is what comes back. If you want to do the same thing for the balance sheet, you can run this command. And the cash flow statement, this command. And here we get more to what we want to do. We want to create some data frames, okay? So I want to take that income statement, but I want to convert it into a pandas data frame to use this 2 data frame like this. And then I want to get all the columns, and then I want to print out all the columns so I can see what they look like. So here you can see the columns. There is a label column, concept column, and then there is these years. So I'm only interested in everything but this concept. I don't need this concept column. So what we're going to do then is we're going to basically create a holder for this all calls here like this. And then from there, I'm going to basically filter out this concept here. That's what this code is doing. It filters out the concept. So here you can see what it looks like now. And then what I want to do is I want to create an income statement data frame. Okay, so we run this, and here you can see what the output is. And there's 23 or so accounts here you can see. All right, so that's the income statement. Moving on, we'll do the same thing for the balance sheet, make that into a data frame and then look at it. So here you can see the balance sheet, but also notice here the concept. You can see this is the concept column we're going to get rid of. Then we want to create a balance sheet column names. They're all going to be the same, by the way. So you could just do it once and you'll probably get the same outputs too. Here we use a slightly different methods to remove the concept by popping it like this. So we'll do that. And now you can see just the label and the years are showing up. All right, do the same thing with a cash flow statement. Here it is. And then we're creating all the columns. We have the concept here, and that's the one we want to get rid of. So let's pop that out too. Here we go. So now you can see you have label and the years. And notice the year is 2025, 2024, 2023. So it goes from the most recent year on the left-hand side here and moving to the oldest year on the right. Okay, so now what we want to do is we want to create a DuckDB database. And that's very straightforward to do in DuckDB and in Python here. You set up a connection object, calling the DuckDB object, or driver, I should say, connect, and here's the name of the database we want to create. Whenever you put something in here, it would automatically create a database that based on whatever path and name you want to use here. So let's run that, and you're going to see it up here on the left-hand side. It's going to create a database, and there it is, Financial DB. And now we want to create some tables to hold the income statement, balance sheet, and cash flow statement. First, we make a copy of the data frame for those columns. And notice we're going to pass in the column names here, and we're going to pass in the data frame. So for income statement, it's going to be the IS_DF. And we're going to use this function to build that. If there's any errors that I wanted to stop, so as you can see here, when errors is set to coerce, if there's a value that you cannot be converting into a number, it will replace it with this NaN, not a number. And then down here, we're creating a type dictionary that's going to hold all the numeric columns. And here we are basically looping through each column, set it equal to a float 64. So we're going to create float 64 if it doesn't have a float 64 type. That way we don't run into problems later. Then we're going to apply the changes to the data frame here. And then we're basically just going to return it. So when you put this all together, we're calling the function here. You can see, go to definition. You can see that's this one, the one we just came from. And then we're passing in the data frame and the column names that we set in cells above here. So that's what we're passing in here. So let's run this. Now we're going to create these newly fixed up data frames. And now let's print them out so you can see the information about each data frame. So here you can see you have Pandas data frame. It says it has these column names, and it tells you the data type. An object in Python terms means string, and the rest of them, all the years here, you can see all the values inside those columns are going to be a float 64. And that was the balance sheet, I believe. Here is the, well, it doesn't matter. It's income statement, balance sheet, and cash flow statement. So that's what these are doing. All right, so that's that one. And you can also do some cleaning using this function here. You can loop through each column and look for certain things. Then you can run this piece of it, okay? Now, this may or may not be necessary at this point. So you can just run it. It's not going to hurt, so you can just run it through. Okay, then here, this is where you clean that stuff, and then you print it after cleaning. But I don't think there's anything to clean up. So it's the same stuff again here, as you can see. Okay, so this is where we actually create the tables, and this is a dynamic query. We're going to pass in a column list, a table name, and a data frame, okay, like a Pandas data frame. So these will be the columns that we're going to generate the table, and this is going to be what the name of the table is, and this is going to be the data frame that we're going to use. So we pass that in, and then you can see this becomes the select clause. We're building a F string here, and we're passing in the values. And then we do a for loop, as you can see here, for each column in calls. And then we're going to create the table with the table name as, and then we're using the join syntax to basically build this list object here into a join, okay, like this. So we put it all together, separated by the comma like this. from the data frame. And then we're going to return the query. So if I run now and look at the tables in my database, you can see there's none, okay? So here's where we're going to basically build it. So let me minimize this part. We call that function, pass in the data frame, pass in the name of the new table we want to create, and it comes from this data frame. Actually, this is the columns that we're going to be building, okay? Sorry. And then we're going to print it, and then we're going to execute it. So let's run that. And I got an error, so let's find out why. All right, the reason I got the error is because I haven't run this function yet. So let me run that first here. Now we can go down here and try it again. So let's run it one more time. And as you can see, it prints out the actual query, the build table query we're going to be using. So here's how we create the income statement and select this as label and this as the column names we're going to be using. And we're converting everything into a double, as you can see here in DuckDB. So this code here will create the tables. And then let's look at and see what the data looks like. And we can open these guys in only retrieving 5 records. You can open one of them and just look in Data Wrangler. And this is what you can see. Here's the first 5 accounts in the income statement. And you can take a look at the Data Wrangler and all the information on your own here. Balance sheet, same thing. Cash flow, same thing. Then we close the connection. And then if you want some additional thing about Edgar, you can play around with this part here if you want to. All right, so that's the end of that file. All right, so the second file basically is going to build some files. So if you look at the very end here, it's going to build the CSV files here for balance sheet. And here is a Parquet file, so you can both of them actually. I'm going to pass in this table name, which is basically going to be which table to analyze. For example, the balance sheet, the income statement, the cash flow. And then this base item is going to be the item that you're going to divide everything on in the vertical. For example, if you're on a balance sheet, you have total assets. That will be the base item, or you can, you use total asset because the total liabilities plus stockholders' equity should equal the total assets. So you can use total assets as a base item that you're going to dividing every account on for vertical analysis. So that's what this one is. And I tell you that right here. You can see that. All right. And then in this case, when we import here, I'm using polars, as you can see, not pandas. So I'm importing DuckDB and polars. Here is how we're going to get the data into a polar data frame. And in DuckDB, you can simply, I can dynamically create it. Select start from income statement, balance sheet, cash flow statements. So this is dynamic, basically passing in this, what comes in on the function name here. Execute the query that you built here, and then you make it into a polar data frame. So that's what this one does. And here I'm looking for everything except label column, because all of them are numeric columns, as you remember. And then I want to sort them. And what this one does is it basically sorts from the most recent year to the left-hand side and the oldest year on the right-hand side. And this is just from printing. We're going to repeat this =, 80 times. Then we're going to, any name, we're going to replace underscores with nothing. And then we're going to write the title, Pro Forma Analysis. Some more printing here. You can look at this yourself. And then here, I'm going to select the label plus the sorted columns that we get from above. So 2024, 2023, and so on, whatever those names are. However, we're going to be doing the horizontal analysis year over year, which is a percentage change. We create a horizontal data frame this way by taking the data frame we're passing in and selecting in the right order here, like this. And then you can see there is a for loop going on here. And the for loop will use a range statement. And if you have 3 years, this one will loop 2 times and calculate 2 changes. So for example, if you have 2024, 2023, and 2022, it will compare 2024 versus 2023 and 2023 versus 2022 because there's a horizontal type of analysis. Then it looks for whether or not you have null values, or if it's 0, right? Then do nothing here. Otherwise, do the computation, do the calculation, because then you can divide here without getting errors. And then you take the absolute value, because otherwise, if you have negative values minus the negative values divided on the negative values, you get some weird percentages. So that's why you use this absolute here, okay? And the alias, you call it change column, whatever the name of the column is. And this will be where you set the change column right here. So you use the current year underscore VS underscore the prior year. So 2024 underscore VS underscore 2023 underscore change percent. So that will be the change column here. That's what you want to call this, okay? And then you can print it out here. And then you do the same thing for vertical analysis. You're checking if the label is equal to the base item. So total assets, you check and see if the whatever row total assets is on, and that will be your base row. And then you can do some printing here, warnings if you don't find anything, return none if there's a problem. And then you can set up your vertical data frame. Same idea here. You set in a certain order, label first, and then 2024, 2023, and so on. Do the same for looping activities here, except for here you're going to basically take whatever column, so 2024 column divided on, let's say it's your balance sheet. So 2024 column in the balance sheet divided on total assets for 2024. You do the whole calculation over the whole column in one shot. You don't loop for each row. You just do the whole column in one shot, much like you do with NumPy kind of calculations. And then you give it an alias, which is whatever the name of that percentage column, which would be basically 2024 underscore PCT, something like that. You get the idea. And then you can reorder columns, set the label, the year values, then the percentages, because we're going to combine the output. So we have the original values in dollars, and we're also going to add columns where we put in the percentage changes and stuff. So we have more columns now because we're going to show dollar figures and percentages in the same output. All right, and then finally, again, we're setting up the table name, the base item. You pass it into this function that's going to actually build it. And that's one of the functions I showed you above here, this one. And then in the very end, once we get all this done, down on the bottom here, this is where we're going to build the combined output in a file format, CSV and Parquet. And then you do some print statements, and then we're done. And then you close the connection. So I can open it in a terminal, I believe, and hit enter. And then what I'm going to do is I'm going to say Python, and then I'm going to say Py. Okay, let's see if that will run. Okay, so it ran. And notice on the right-hand side here, I created a balance sheet, CSV. I created a Parquet for balance sheet, cash flow, CSV, cash flow, Parquet, and down here, income statement. And another nice thing you can do here, either for Parquet and as well as CSV, what you can do is you can right-click on these guys, and you can say Open in Data Wrangler. And look how nice. It opens as a regular file in Data Wrangler. For example, I can move this down. So here you can see all the columns and the distribution for each column in Data Wrangler. And this is the Parquet file. And I can also do like a CSV, and it looks the same. So it's very nice the way they set this up. And here you can see that one. Okay, so that's a little bit about that. Now we got a database CSV file, and we got the Parquet file. So now we're ready to look at that third and final file. This is the Quarto document that builds the actual output. So you can see here, you create a title. It's using some HTML settings like table of content, and it shows you code fold, whether you want it to be open or closed. And you can have a format like a theme for Cosmo in this case. And here you set up the financial statement analysis. In this case, it should not be AbbVie, it should be NVIDIA, right? Okay, so I fixed it, changed the name. And here you can see we are going to run some code here for vertical and horizontal analysis. And we're importing DuckDB because we're going to go against, in this one, we're going to go against the Parquet files. We're not going to go against the database in this case. We're going to go against this Pro Forma Parquet files. And that's why I'm importing DuckDB, because I'm going to run queries against and get data that way, directly against the files. And I create a polars data frame again using the polars library. And we're also going to create markdown. So I need to import from IPython display. I'm going to import markdown and display. Here we create the connection to DuckDB. Here we have a function called format labels. And again, I'm not going to go into detail on every line here. So you have format number here, and it goes against this polar series and has the values for each one. And keep in mind these polar data frames, you work on a column over column. So when you do one calculation, you can do it over the whole column in one shot. You don't have to loop through every row. Yeah, so it's basically a bunch of formatting here. That's what all this is doing. And you can kind of study up on this from kind of following the code line by line or jump around as you please. But the bottom line is we're going to set it up so if it's a big number, right, when you take the value and divide on this, we want to make it into like 1,000,000. We do it this way. We use an F string and you use dollar signs like this. So this is all just to make it look nice on the output. Here we're going to actually create the markdown table, and notice we're passing in a Parquet file, a title of the output, and we also have a max label width, which we set to a default of 35. So let me make this a little wider here. So here is the query we're going to run against the Parquet files, this one. So it'll be one for income statement, one for balance sheet, one from whatever. The names of these files are up here, this one. So for example, select star from balance sheet _ pro forma.parquet, something like that. And then we execute that query and we build a data frame out of it here. And then we do some list comprehensions here, and we check and make sure that the column name is not the label column, for example. That would be the data columns. And here's the value columns. Again, if it's not ending with a percentage, then, it'll be a numeric, meaning $1. And again, you also look for whether or not the column name ends with _PCT, for example. So if it ends with this or it ends with this, then most likely it would be a data column in dollar terms, okay? All right, so it builds up a bunch of stuff here. And here you can see it builds a table. There's the header of the table. You can see these vertical bars. So that's how it's going to organize the table into columns, basically. And then it does some looping. It will replace this stuff with nothing. So it only grabs the year, for example. And it has replacement of this using this. So it looks nicer when you print it out. Okay, so here you add all the data rows in this piece. And again, there's a lot of formatting, billions, millions, thousands, etc. Then you do all this looping. You append these lines to build that document, the markdown document. And this is basically how you call it. And this is the same for the next two functions too. So you create a balance sheet table here. Call this function we just went through up here where you create the actual output. Pass in the file name and pass in the title you want to use for that output. And here you can set the max label width. So that would be the name of each account basically. And here you're going to display the markdown based on the output here, okay? And then there's an exception to print that out. And it's the same thing here, and it's the same thing here. So there's nothing new. And then you close the connection down here, and then there's just some stuff that explains how this is formatted, etc. So that's basically it. So let's try to run this now and see if we can actually get output from it. So you can use Quarto, render, and then the name of the file. Let's see if this will work. So I'm running it. Hopefully it does something. Starting the Python kernel. Done. Okay. All the steps are listed. And here it starts building it. Okay, it looks like it did it. And it created an HTML file. So let's take a look and see what it will look like. So let's open with live server. And here it is. Okay. And if you look at it, it created a title. Here is the financial statement analysis for NVIDIA. Maybe I should remove this stuff. Let's put it one lower here, make it a little smaller. But as you can see, it has the label. And you can see here 2020 is on the right-hand side. And then you have these versus base. So that would be like cash and cash equivalent is 7.7% of total assets. So if you look down here, here's total assets. That was the base. So it would always be like 100% there because it's vertical analysis. And then you also have horizontal on the same sheet, which is kind of nice. So you get the vertical interpretation versus base. And then you have the year over year. So 2025 versus 2024, year over year. You can see the percentage changes here. So that's the balance sheet. It might be a little busy. You might want to break this into more than one statement. You have the code, so you can just fix it up the way you want it. And here, of course, is the income statement. One thing that you're going to notice here, see, there is the billions, right? It's in billions. There's a couple of things here that you might have to fix. Number of shares. Well, you probably do want them in billions, but you don't want the dollar sign. So that is something you might want to have to go and fix. And you just have to go in and fix it wherever you format this stuff for the vertical analysis or for any of the dollar figures. You can maybe look for it and see if it is this account that starts with shares outstanding or something. You might want to fix that. So I'll leave that up to you. I'm not going to try to do it now. All right, so that's the financial statements. And then down here, you can see here is the notes. And here you can see the data sources that I used to produce this document. One thing I want to point out is that if you look at the Pro Forma financial statements, notice it comes like this. Now this is probably the filing date. That's not the format you want because it was issued on the 26th of January 2025, but the numbers represents the year of 2024. So it's kind of misleading. This should really say 2024, this should be 2023, this should be 2022 because it's the year after the actual statements was issued. So if you look now here, I created a section here at the end of this get_fin_statements iron Python notebook. And if you look here, I have different methods you can use to try to fix this. So you can hard code it like it's in the first method. You can parse it with some dynamic logic. And I'm not going to dwell on this, but you can try it out yourself. But you can see here is how it prints out when you run that code. And then you can also use simple year extraction, which is this code. And here again, you can see the output for that. Finally, you can see this is the company-aware physical year converter. And again, there's a lot of logic here. And depending on your needs, you can try this out yourself. I'm going to push this out to GitHub. So you're going to have access to this notebook. And I will include this stuff in there. So if you want to do some more to your Pro Forma financial statements, you can use some of these techniques. I hope you liked this video. And if you do, please give me a like and consider subscribing to my channel. It'd be fantastic. I hope this was helpful, and I look forward to see you in the next video. Thank you so much.